Okay, so this is a classic titration exam question. I know it is because it tells me here that it's a titration, but not only that, the fact that it's got 250 centimetre cubed solutions being made up, 25 cm cube portion. Do you remember using the pipettes? And then here is an average titra value. So all of those things tell me that this is going to be about titration, and it's not scary because all I need to do is just bear in mind my 4-step titration calculation framework and it'll all be absolutely fine. So the first thing we need to do is we need to go through and have a look at all the different data that is being given us. So we've got the name of the sample here, we've got the formula over here, we have got the mass of the sample there, 3.01 grams. It's being made up to 250 cm cubed. It's a 25 cm cube portion. Again, here's your average titra. This is the concentration of the hydrochloric acid, and then it goes on and starts with the questions that we actually need to pay attention to. So, just moving things out the way. The very first thing that we notice is the question is very broken down for us. So all of these different steps here allow us to do the titration calculation in a series of small steps rather than doing the calculation in the bigger way that we've done it before. So it's as simple as going through it and working out bit by bit what is required. So first one, okay, we have all our values, okay, and the first thing up here it says calculate the number of moles of HCl in 24.3 cm cubed, which is our average titra, and it gives us, again, it reminds us of the concentration. So all I'm doing for this one is I'm using moles is concentration times volume, and we're remembering that our volume has got to be in dm cubed. So we take this and we divide it by 1,000 before we get our dm cubed. Okay, so the number of moles then becomes 0.200 times by 24.3 divided by 1,000. Now, I would be very careful when you're doing this with your, just refocus that a little bit, when you're doing this with your calculators, different calculators have got different ways of processing. So by all means, if you have the fancy pants calculators where you can put brackets in, or you can order which steps these happen, but you need to test this a few times through and make sure that you're getting the answers that you need to be getting, rather than finding out later on in the exam that your calculator has worked in a different way and you've ended up with a slightly different answer because of it. If in doubt, do everything longhand. So therefore, do your 24.3 divided by 1,000 first, press equals, and then do times by 0.2, in which case your answer should be 0.00486. Okay, next one. Deduce the number of moles of sodium carbonate in 25 cm cubed in the solution. So this is where we go back up to our equation. Now from your equation you can see that you've got a 1 to 2 ratio, here's your 2, of sodium carbonate to hydrochloric acid. So that tells us that for every 2 moles of acid we've only got 1 mole of sodium carbonate. So let's have a look at this. We've got this many moles of acid. The question is very nicely leading us to the next bit. We must have 0.00486 divided by 2 moles of sodium carbonate, which is 0.00243. Okay, next one. Deduce the number of moles of sodium carbonate in the original 250 cm cube solution. Again, it's leading us very nicely from one step to another step to another step, and we just need to make sure we're following through and we're reading everything properly. So what do we need to know about this one? Well, we know that we had 0.00243 moles in 25 cm cubed. But here we're being asked about 250, so this is simply multiplying by a factor of 10. Okay, so it's as simple as saying it's 0.0243 moles times by 10, which is 0.0243 moles per 250 cm cubed. And the final part of the question, like I said, leading you through really nicely, it didn't have to be so kind, is calculate the relative mass of the hydrated sodium carbonate. Well, you have got a value for moles, and if we look back at the top of the question, it did tell you that 3.01 grams of the sample was used to make that 250 cm cubed. So we know that 0.0243 moles are in 3.01 grams. Oops, decimal place in the wrong place. Do apologise. Okay, 3.01 grams. So what we want to know is what is the relative mass for the sodium carbonate as it is. And if you can remember, the relative mass is always the mass of 1 mole in grams. So really what we want to know is how heavy is 1 mole. Okay, so how are we doing this? Well, what we want to do is we want to make this number 1, because if we can make this number 1, it will make this number the correct value for the weight per grams. So to make this number 1, you simply divide it by itself. Okay, and then you'd have to do the same on the other side. So 3.01 divided by 0.241. Oh, I beg your pardon, 243. I missed a 0 here? I certainly have. Okay, so we've got this number here, 0.0243 divided by itself becomes 1. And then we work this out here, 3.01 divided by 0.0243, which gives you 123.86 atomic mass units. Okay, or in this case it would be grams actually, because grams is up here. So we're going to make that grams. I do apologise for the number of mistakes I've made. I've only had 4 hours sleep today. Now that's the end of that question, and that would be 5 marks. However, you could take this further, and some questions will do, and they'll ask you about integers, which is another thing that freaks people out completely. So the integer is the little number that you saw, the little x that you saw in the formula. So we've got sodium carbonate, and then there was a dot, and then there was X H2O. Well, the X here is the integer. Okay, and the reason why it's dot X H2O is because when this forms into a hydrated crystal, this here in fact is the water of crystallization, which will surround the crystal and give it its shape. It's not part of the sodium carbonate, but it's part of the crystalline structure. These values have all got different values in different crystals. For example, copper sulfate crystals normally have an integer of 6. But in this case, we could actually work out what that integer was if we felt pretty brave. And sometimes exam questions will ask you to do it, and it seems scary, but it's not, because look at this. We know that 1 mole of the hydrated crystals, in other words, this whole thing with this water in it as well, is 123.86 grams. Okay, if we work out the relative mass of just sodium carbonate on its own with no water, then we're looking at, well, let's figure it out now. 2 lots of sodium is 46. Then we've got a carbon, and then we've got 3 lots of oxygen, which is 48. And if we add all those together, you get 106. Yes? Okay. So when we look at that and we look at the difference between the two, if you do 123, can you see that okay? 0.86, take away 106. Now, I haven't used all the decimal places here. I've only done approximate relative mass units, so you'll have to forgive me. This isn't going to be dead on, but 123.86 take away 106, it gives you 17.86. Now, the relative mass for water is 18. So I'm hoping that you can see that that is practically 18. And that means that this value here of x has got to be 1. Because the difference between the total mass and the mass of sodium carbonate on its own is just the relative mass of water. So if they ask you a question about integers, please don't freak out. Bye-bye.